At Dave Cooper Live, we connect the industry leaders in the architectural, engineering, and construction space with the people, the products, and the processes to help them build it better. All right, welcome everybody to Dave Cooper Live, where we connect the industry leaders in the AEC space with the people, the products, and the processes, helping us all to build it better. And today we're tackling the future of construction with 3D printing technology. Joining us is Philip Lund-Nielsen, co-founder and head of Americas at COBOD. COBOD is transforming construction, delivering projects faster, more sustainably, and at lower cost, from single-family homes to multi-story buildings. Their 3D printing solutions are setting new standards. Well, we're going to dive in and explore how COBOD is shaping the future of construction right after a word from our sponsors. Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory, optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. Howick Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, howickltd.com. Brought to you by Greatech, one of the largest Autodesk partners globally and software developer of the PowerPack Advanced Design, Advanced Steel, and the StruxSoft product line. The complete solution to automate wood and light gauge steel framing, design, and documentation all the way out to CNC output, model, design, and manufacture with StruxSoft. Learn more at StruxSoftSolutions.com. All right. Again, thank you to all of our sponsors, supporting members, and everybody that comes on this show. Without those supporting members, we cannot continue to bring all these innovative conversations and companies like Philip Lund-Nielsen's, who we're going to bring on right now. Philip, welcome to the Dave Cooper Live show.
Thanks, Dave. And thanks for the warm intro.
Hey, listen, you deserve a warm intro. Everybody does. That's really trying to change how we build and what we do. But Philip, before we get into COBOD and what you're doing there, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will have your mother on, or a family member, or somebody, and I'm sure it'll get embarrassing, but you only got 2 minutes to do it. The floor is yours.
Thanks, Dave. So you did actually mention the hospital there, and that's sort of where this whole journey got started. I got into a big accident around 10 years ago. I had to drop out of college, and I got a call from my uncle asking me if I wanted to test out a small-scale plastic 3D printer. After a lot of trial and error, I sort of got that printer to work. We stumbled across some engineers with whom we started a small store in Copenhagen, Denmark, where I'm from, where we resold these 3D printers that could print, say, an iPhone cover or print nuts and bolts and stuff like that for the home. After a few years, we said, okay, the potential here, this technology is fantastic, but could we apply it on a bigger scale? Now, construction is the world's largest industry, and it's a very, very good industry, but it also has its challenges. And we thought, hey, maybe actually construction could take great advantage of applying 3D printing. So we went ahead, and in 2017, we 3D printed Europe's first 3D printed building. 2 years later, we started reselling these machines, and now we're basically based all around the globe where we manufacture, we develop, and we sell 3D printers for the construction industry. So you could say, Dave, to summarize my story in just 2 minutes, or at least COBOD's, we've gone from selling 3D printers for the home to selling 3D printers that print actual homes.
It's funny. So you went from an accident, which knocked you out of college, but sometimes maybe things happen for a reason, right? Because look at you, man. You got a global 3D printing company, and I think it's fantastic. Out of bad things, there's always good things that come out of things as well, or out of trial and tribulation. So, Philip, love the backstory. Love the fact that you started selling 3D printers. And I also agree, it does have a place in our society for building new homes and more affordable homes. I mean, heck, they're even 3D printing food now. Think about that. How do you print something you can eat? But they're doing it. So I can only see this technology getting much more advanced.
For sure. 3D printing has actually existed for decades. And 3D printing in concrete is just a new way of applying this technology. And that's actually a truth with modifications, because if you go back to the 1930s in Indiana, there was a guy, I believe his name was William Herschel, who had what he called a wall depositing machine or something like that, in which it actually looks like the initial step towards 3D printing, because the machine deposited concrete in these round cylinders to create a physical structure. So the technology is new, but it actually started many, many decades ago, you could say.
No kidding. Well, everything starts somewhere. So let's get into what's going on exactly with COBOD here. We have a presentation for you, everybody. So if you are just joining us, we are talking about the future of construction with 3D printing. We got Philip Lund-Nielsen, co-founder and of COBOD International, but you're also the head of Americas. I'm assuming that's North and South America and everything in between.
Correct. So 2 years ago, I moved here to Miami, Florida from Copenhagen, Denmark, where we started the whole thing, because we wanted to get closer to our customers. As you guys know, construction is a very local industry, local practices, local architectural styles, local materials, right? We wanted to be closer to where our customers were at. Now, it just happens that we have a lot of customers here in the US, in Canada, but also in Latin America, for which Miami is sort of smack there in the middle.
Let's hop into it, Philip. Let's take a look at everything you're doing. And then near the end of this, I really want to talk about where you're headed, where you see the future's headed. And you can leave us with some final words. So I'm going to put your presentation up on the screen if you're ready for it.
Sounds good. So just shortly about COBOD, we're the world's biggest supplier of 3D printers for the construction industry. We have 3 offices. We have the Copenhagen office in Denmark. We have some regional facilities here in Miami, and we got our facilities in Malaysia as well. We started in that basement in Copenhagen, I mentioned before, just 5 guys. Now that we have 100 employees. We recently sold our printer number 81, I believe. So we're on all 6 continents.
Wow.
And we do 3 things, right? We develop and we manufacture and we sell these machines. However, we're also doing a lot of partnerships with great global and local companies to bring this technology to life. One example is, for instance, General Electric, with whom we're printing wind turbine towers. It's not just for housing, as you'll see in just a bit. It has a lot of different application areas besides just residential housing, which you usually see.
Yeah.
Here, just a quick word from our sponsors. So we thought in order to really push this technology and really have it be adopted in the world's largest industry, we need to have investors. We need to have the strategic backing of companies that are specialized within that industry, right? So when it comes to constructing, say, wind energy, right, or driving the green energy agenda forward, General Electric is the place, or is one of the companies you want to work with. If we're talking concrete, well, Holcim and Cemex, world's number 1 and world's number 5, the biggest concrete cement suppliers, are very good to have as investors too. Mm-hmm. Now, Perry, one of our first investors, is the largest manufacturer of scaffolding in the world, and all these players have been helping us push this tech forward.
That's great. That's great. When did you get your first sponsor?
We got our first sponsor from Perry, and that was around 4 years ago. And then we had the other 3, GE, Holcim, and Cemex, join as investors in 2022.
Got it. And when was your first prototype built for your printer?
That was in 2017. So
got it.
already 7 years have passed since we did the first one. It's just crazy how rapid this industry is moving forward. Not just for us, but for all the other companies and players out there.
Yeah, for sure. In fact, I'm gonna just add to the screen here while you're teeing up your next document there. But this is your printer here, and obviously you guys are just doing a little demo there. But I'll let this play a little bit, and you let me know if you want to talk about it or if you want to get back to your presentation.
Sure. Yeah, here you can see the concrete being deposited. Some of our local or global partners, I should say. Here again, it's deposited. Notice how the nozzle actually allows for it can move in 3D space and sort of turn around and automatically travel as the printer goes. You see there?
Yeah.
Stop it right there, which is a unique feature of our system, is that you avoid having these bulging walls where the layers are very visible. And instead, if people can sort of look at me again, instead you have, here's just a sample, right?
I'll hold it up.
Where you can tell here it's very, very flat.
It is very, very flat. And that's all because it's troweling at the same time that it's laying.
Exactly. But notice how, even though you can make out like the individual layers barely here, but if you look from the side, it's completely monolithic, right? So this is very, very strong. It's as strong as regular concrete because we're big advocates of our customers mixing concrete locally
right.
Because it has certain advantages over industrial products that are, say, manufactured in a plant and then shipped on site.
Your concrete, is it a proprietary blend? Is it something that you have developed and perfected over the years now, or is it what everybody else is using out there?
We're completely open source. We said from the beginning, hey, we don't want to be like I think that the 2D printer industry was, like the paper printer industry was, where you buy a super expensive paper printer, but then you're locked down to certain inks and toners. And then that's where they make the money. We have no interest in that model. So instead, we went ahead and we developed a batch plan. You stop the video right there, Dave. Upper right-hand corner. If you just go back just a few seconds, you can actually see in the upper right-hand corner, exactly up there, that's a concrete batch plan. You can see the sand, you can see the aggregates and the cement.
Yep.
And then our customers, they mix it there, locally sourced ingredients. It's 99% real concrete, and then admixtures that makes it 3D printable.
Got it. Got it. So you're able to cut down on the logistics of the material you need because you're able to source local material for the processing and batch plants right there.
That's correct. That's correct. And it means a lot. If you're doing, like, let's just talk cost to begin with. If we compare to, say, dry mix mortars, which they have certain benefits, but cost is not one of them.
Yeah.
We're typically talking like 600, 800 to $1,000 per cubic yard. Whereas if you mix concrete locally, now the U.S. is a big country, so it will differ, but we're probably talking maybe like 150 to $300 a cubic yard, right? Which means if you're doing a one bedroom, one bathroom house, you're saving at least, I would say, $20,000 on just the materials by printing with local concrete constituents.
Got it. Got it. And single family or multi family, or even you guys have done, I think, the tallest building now out of 3D printed concrete, correct?
Yeah, well, we can't take all the credit for it. We're not a construction company, so it's only our customers
Right.
that they do the printing. We just sell them the technology that enable that printing.
Got it. Got it. Got it. Love it. Love it. All right, well, let's hop back into your deck here and keep rocking and rolling.
Sure. I might jump over a few slides that are not that relevant, so bear with me. But you can see here our footprint is very, very broad across the globe. And the same applies really to our customer types, right? It's not just construction companies for conventional homes. We have developers, we have concrete manufacturers, wind turbine manufacturers, academic institutions, et cetera, et cetera. So this page just tells me there is definitely room for this technology somewhere in the world with some kind of application.
Yeah, for sure.
Here's the U.S. Alone. So if you're in a state that hasn't got a pin yet, please do reach out afterwards. No, just kidding. This we can skip. Here's the meat of it. We really have two things that we sell as part of our package. One is the 3D printer itself. We call that the BOD 2, because it's second generation, and it stands for Building on Demand. That's actually how we got our company name. First, the first printer we called it Building on Demand, or the BOD.
Yeah.
But afterwards, we started selling these machines, so we became a company of buildings on demand, COBOD, which it rhymes with COBOD, so it rhymes also with robot. Yeah. Sometimes confused with COVID a few years ago, but that's what we do. And the second part is the batch plant. So that's what we talked about before, mixing concrete locally. And the machine is completely modular, meaning we can extend it in the height up to around 30 feet, in the width up to around 40 feet, and in the length, you can basically go as long as you want by adding those extra towers to fit your specific project.
Got it. So tell me, how mobile is it? So if I want to go up multiple stories, I can go up roughly 25 feet. Then I got to move the unit up to the next level and start printing again.
So it actually prints, it sort of it goes around the full building up to the 30 feet. It's not moving up. So here's an example. You mentioned before the world's tallest 3D printed building. Yeah. Which is what you see here. This is done in Saudi Arabia by Dar Al-Khan. Dar Al-Khan is one of the largest, if not the largest, builder developer in Saudi Arabia. So here you can see the printer at its full height. It's printed this building, which is just over 30 feet tall. So that's 3 stories, and just shy of 4,000 square feet. It's really quite a beautiful building.
That's impressive. Great. Is that part of the line project or NEOM, or where is this?
It's not part of the line, but that would be quite interesting to see how that could be printed. I think the line they're doing is it like 170 kilometers or like 105 miles or something like that of city?
Yeah, it is. It is. And they need your printers, man, because I tell you what, they have the Olympics coming. I believe it's 2030, and there's not a whole lot done yet. So I'll be sitting on pins and needles watching how they pull this together over the next several years.
Yeah, well, I'm sure if they grit their teeth, they can have it. They can get it done. But they're more than welcome to call me for printers or my colleagues in the Middle East. If nothing else, I'd really love to go to the Olympics. So
Yeah, there you
the
go.
excuse.
We'll see. If you get an invitation, make sure you reach back out to me and take me as your buddy.
Yeah, for sure, we'll do. So here's just one example of the building, 3-story tall. Here's another one. This is, or was, I think, at the time, the fastest and also the largest 3D build project. What they did here, this is in Kenya, Africa. Our investor Holcim, they printed 10 buildings in 10 weeks using just one 3D printer. So around 8,000 square feet total. And it's quite staggering how fast they did this. I mean, yes, here in the U.S. and elsewhere, you could probably have framers do a similar building in maybe a week, but in many cases it will take longer. And that is, you can even find the crew to begin with, because Dave, as you might know, here in the U.S. There is a worker shortage in the industry of, I think, at least 500,000 workers.
Oh yeah, if not more.
Yeah. So that's really, I guess, what we're trying to address with automation like ours is it reduces the need for this very, very scarce and important workforce. While simultaneously it actually upskills them, right? Which hopefully should also come with some salary benefits too.
Yeah, for sure. Can you run 2 printers simultaneously at the same time so they meet in the middle, or does that just not make sense?
You could. I mean, we have customers that have worked 2 printers on site at the same time. You might need 2 batch planes to run simultaneously as well. But as you know, the more printers you add, the faster these projects go. So that's definitely a possibility.
And how many crew members does it take to set up a printer to start printing and run the batch plant? So I'm sure there's more to set it up and less to run the batch plant.
Yeah, correct. So in general, we're talking a crew of 3 to 4 people. I can actually jump further down the presentation and show you who those people are. And as you said, it's well, maybe I don't have that in here. It's maybe I'll just find a site so that we can show it. So here, like if I go back to this one, you have the 3D printer there. Which requires basically just an operator. So the operator is ensuring that the print comes out as intended in the digital file. And that could be an architect, could be an engineer. We have a 3-week training program that can take most people up to be able to be good operators within that time frame. So that's one person. The other person is operating the batch plant. So that's where you mix the concrete. And now I'm going to jump a few pages again, because this is what we also discussed before about how the concrete is being mixed. So this is what the person in charge of the batch plant does. They mix locally, they mix the 3D printable concrete by first taking real concrete, and that's mixed there in the batch plant to the side. That's your aggregates, water, and cement. And then they tweak the admixture level to make it 3D printable. And there's sort of 2 components to it. One is a plasticizer to make it more pumpable. But once the 3D printer starts extruding and it comes out the print head, then you want it to be, it has to have a certain viscosity to not come out as a complete slump, but instead be stacked in layers on top of each other. So that's what the second person does on a construction site, is ensuring that the layers and the concrete is mixed correctly.
Got it. So they're overseeing that what's coming out of the end side of it is doing what it's supposed to do. And if not, then they go back and adjust it.
Exactly. The temperatures might vary greatly from the morning till the afternoon. and that's why it's important to be able to tweak the mix accordingly to get a consistent result.
Yeah, understood.
So that's the second person, and then the third person is somebody that's good at using his or her hands. They could support with, for instance, say refilling the silo for the concrete constituents to the batch plant.
Got it. Awesome. So with that said, how many current projects you guys have going on right now?
Current projects, worldwide, it's hard to say. I can say at least that there is multiple projects going on each continent.
Right.
One of our customers recently finished here last Friday the first 3D printed house in Tennessee, at least to our knowledge. So some news will come out about that later. And it's really fantastic to see what and how often our customers print using our technology.
Yeah, for sure. Well, here you go. I'm going to hop back into your presentation.
Sure. I mean, I can just show a few more examples. It's probably more interesting than just listening to me talk. Here's one in Florida, the first permanent 3D printed house up in Tallahassee, around 1,200 square feet. Yep. Now, David, when you look at this, like if you just went past it, would you think this was 3D printed?
I would not. In fact, knowing what I know, if I was up close, I could probably tell if they didn't finish off the siding on it. But no, that looks like a regular house to me.
Yeah, no, same here. The only telltale, and that's probably just because I mean, we're the ones behind the technology, but you can tell that the sides there to the right are just slightly curved because you can never achieve like a fully perfect 90-degree angle because the print head will move around in a curve. But other than that, it looks like a completely conventional home.
Yeah, 100%. I would listen. I'd live in a concrete home all day long.
Yeah, no, for sure, same here. And there's many good examples of how that you could say design freedom is being used. Here's a bit of an older project. This is actually our first customer, so we appreciate them a lot. From Belgium, 1,000 square feet and 2 floors. You can see how that building is very, very curved on the side. And Dave, I mean, if a crew was to do this with conventional methods, say CMU block or framing conventionally, how long do you think it would take?
Oh, listen, it's probably 3, 4, or 5 times the setup time would be the same amount of time as printing the house. My guess would be, if not longer.
Yep, and that's just the speed, right? Then there's the cost. Like it would probably be cost prohibitive to do something like this with conventional methods.
Yeah.
But with 3D printing, the printer doesn't really care if it's going in a straight line, if it's going in circles, if it's doing eighths. It's just a 3D space for it that it moves around it.
Yeah, and you can tell from this angle, it looks like that ceiling is even sloped as well, and that printer is able to print a sloped ceiling like that as well.
We have had customers that have printed roofs. What they do is it's a combination of formwork with 3D printing. So actually, you would 3D print the formwork, just a few inches of say the perimeter of that roof and that roof structure.
Right.
Place reinforcement and then cast and backfill with concrete to get a smooth layer.
Yeah, got it. I don't know why I was saying ceiling, but you're right. The roof. So yeah,
that's what they did for this project. Actually, the roof here, unfortunately, it's a bit hard to see from this angle, but the roof for this building was actually 3D printed. It's a small student building in Denmark.
Yeah, that's awesome.
Mm-hmm.
How are you doing the installation while you're printing?
Good question too. What our customers do is typically that they print an exterior wall and an interior wall, and that leaves a cavity there in the middle. Now the cavity on its own actually has some insulating properties because it's air gap, right? It's air that's trapped. Yep. But what our customers then do is they would add any type of insulation. So that could be mineral wool, it could be spray and foam, or otherwise added subsequently.
Got it. What? Tell me a little bit about how this works. Do I buy the printer from you in the mixing plant? Do I lease the printer in the mixing plant? If I had a project, how long would it take me to get a printer in a mixing plant? Give me the lowdown on what it takes to get involved in this.
Sure. So right now we have two ways of selling the equipment,
Yeah.
either directly through us or through our local distributors.
Mhm.
We have started to see some of our customers and distributors that have done leasing. So they would sublease to somebody else for varying prices per like on a daily rate, I think. And I think we're going to see more of that, Dave, because you know a lot about the conventional construction industry. For the most part, I don't think you buy a crane, right? You go and lease it instead. No?
Yeah. I mean, for the most part, most of the equipment, unless you're a huge concrete, sub, you're not going to own everything that you need.
Exactly. So this is part of the industry becoming more and more mature. We're going to see different kinds of leasing options because I mean it's good equipment that we sell, so it also comes with a price tag that is it's up there, right? So they start from around 500,000, but some of the printers we've sold they've been north of 1 million, albeit they're very very large, but it's still a big investment for undertaking a very, very new technology to your construction site.
Yeah. What is the speed to market savings, right? Because that's what we're talking about, speed here. From traditional construction on like that house you showed us, that White House, it was probably what, 1,200, 1,800 square feet, maybe, or something like that.
Yeah, the one we saw before was 1,200 square
Yeah.
feet. This one here, yeah.
Yeah. Let me I'll add it back to the screen here.
So this one, I believe it was done in less than 2 work weeks, and that varies with each customer. Here
Yeah.
we're in California. They did 7 homes of the same design. And the first one, I believe, took more than a month, but the last one they did was done in, I believe, just like 5 or 6 work days.
Yeah.
So the learning curve is so steep, but it's very important to do multiple projects because if you don't, then I'm just going to be honest, Dave. Like you need scale in order for this, in order for it to make sense to invest in this technology. The first home you're going to do, contrary to what you might hear in the media and from other peers in the industry, it will take time before you reap the benefits both of cost, on speed, and sustainability. So doing just 1 or 2 single family homes a year, you know that's going to not be enough
Yeah.
to bring home that investment.
Right, right. So I mean, yeah, I understand. It's going to take mass. Talk to me about finishing, right? How are you running the wires? Are you putting layers of sheetrock in front of this and furring it out on the inside? How's that being done?
That varies a lot from customer to customer as well.
Yeah,
Some like to do some simple stuccoing to match it with the local neighborhood.
sure.
Others they leave the concrete completely bare so you can see the layers. I mean, there's some customers that their end customers, the ones living in the buildings, they prefer having the concrete look like this because it demonstrates, hey, I live in a 3D printed home, right? There's the novelty factor as part of that. If you see anybody driving a cycle truck, that's also a new okay, it's a car, but it looks differently from everything else, right? And they want to show
Right.
off, and I think to some extent that's what they do for 3D printed homes too.
Yeah, no, I definitely agree with that. I definitely agree with that. All right, so let's talk a little bit about some of the customers that are using this. I'm going to flash up your website here if that's okay with you, and then we can kind of jump into who's using this, who are you looking for as customers right now, and then we'll wrap it up. Sound good?
Sounds good. Always happy to speak about our customers. Where do you want to jump in? You can see there's various categories there at the top.
Yeah, got it.
Cement companies, construction companies, real estate developers.
Got it. So these are some of then if I just click through these, it gives everybody some idea who's who, universities, R&D facilities.
Yep, exactly. And it's not exhaustive. We have more. We just updated the website, so there's more being added. As
Yeah.
mentioned, there's 80 printers out there in the world. Click on that one. I think
Okay.
because if we talk about something else than just housing, if you just go down a bit, what's interesting about this, so here you can see we 3D printed these massive wind turbine towers. If you scroll down a bit, you can see it in its full capacity. This one here, you're seeing it from up top, is actually 30 feet tall. And why do we want to 3D print wind turbine bases? I'll explain it. So right now, the wind energy industry is characterized by it's predominantly land-based wind turbines, and they max out at around 300 feet in height.
Okay.
And that's a shame because the higher you go, the stronger and more steadier winds you can get, right? But they max out at around 300 feet in height because they're shaped like cones. So they're wider at the bottom. But the bottom modules that are produced in the factory, they actually cannot go wider because of road restrictions, because of truck restrictions. So even here in the US, where you guys do have massive roads, if anybody has been on Katy Freeway in Texas, 27 lanes, it's just crazy. But for roads, you cannot have wider modules for the trucks. And that limits or that puts a cap at around 300 feet. But our idea is, why don't we 3D print these modules, larger modules, on site in concrete? So it's a factory on wheels that you put on site, 3D print them up to maybe up to 100 feet or maybe even more in height, and then you stack the conventional turbine on top in steel. So in that way, you can get extra height and more energy output.
And how do you reinforce that concrete when you get to those cylinders and those heights? Like how do you reinforce that? You putting rebar in steel, or do you not need to do any of that?
There's various ways that our customers reinforce, and it all depends on the structure you're doing and also the local building codes. So for this wind turbine tower, that was printed as a whole, and then afterwards you had cables that were preset post-tension cables throughout the structure in the vertical plane. In addition, in the horizontal plane, to prevent outward stresses, because it's 100 plus tons of concrete, you had these radial, you had these rebar rings that were added every, say, 3 or 5 feet to make it even stronger.
Love it. Let's talk about the solutions you guys offer here. So we come to a wrap of the show here, but here I have the your wheel of solutions, as I'd like to call it, right?
Yeah. I actually don't like that figure there because we're moving away. I think it's confusing. But what we sell very simply is it's materials. It's a material solution. So mixing concrete locally. You need something to print with that concrete with. That's our 3D printer that you see there.
Yeah.
And then lastly, it's the training and it's the servicing. You will need training to get going. Operating this kind of equipment is a steep learning curve, and we can accelerate that. And that's why we go on site with our customers for 2 weeks to make it happen.
Is there anything that I left out, Philip? We're coming up on the closing of our show here in just a few minutes, but I want to make sure we covered everything. Are you looking for new partners? Are you looking for people to buy more printers? Tell us what you're looking for and how maybe Dave Cooper Live's audience can reach out and help you.
Sounds good. I think we got around a lot of the good areas of this industry here. If anybody wants to, let me put it this way. Let me end where I started off. I said the construction industry is the world's largest, and it is. It's around $14 trillion. It's huge on a global scale. But construction is also, it has some challenges, right? It's not that automated compared to other industries. There's a lack of skilled labor. it doesn't always have the most sustainable practices. It makes up 40% of global CO2 emissions. It lacks design freedom in many cases. I mean, go out to any suburbia in your area, and many of the homes will probably look exactly the same next to each other. So if you face in your industry, if you have any of those challenges, if you see those challenges, and if you want to address them head on using very cool new technology, then please call us, because then you're the right partner for COBOD.
Love it. I'm going to put a comment up and then one question, and we're going to call it a wrap. Joel Hutchins, what's happening, Joel? Good afternoon, team. Well, good to see you, Joel. Joel's down in sunny Florida as well. You guys should connect. I think he's in that West Palm, Miami. Maybe I'm wrong. Maybe he's West Coast. I don't know, but go check it out, Joel. All right. And then here's no stranger to the questions. Henry Mickelberg says 3D printed concrete is a superstructure solution. Typically, the superstructure is 15% of the overall cost. I want pros and cons, like for like comparisons of my superstructure options to objectively inform my construction methodology choice. How do you present the metrics and prove that 3D printing is the best choice? It's a great question.
Great question, Henry. And it's a great question because I have a great answer. Well, I'll let you be the judge of the answer, but it's a question we get quite a lot. Like, show me the money, because of course, if I am to sell a 3D printer starting at $500,000, how much cheaper is it? How much faster is it, et cetera? And Henry, you bring up a good point in that. I would say the superstructure, it makes up around 15 to maybe 25, maybe 30%, depending on which area you're in. So if you're saving, say, 10% of, let's just take your number of 15, that's 1.5% overall for the project, which it doesn't really sound a lot. I know construction in general has lower margins, so it is, it is meaningful, but it's not, you're not addressing all construction side costs. There's still a lot of other activities that are being done the same way. And that's why at COBOD, what we do every day is to try and increase the amount of activities that are being addressed on a construction side. So what can we do to improve the printing process itself to make it even cheaper, make it even faster than conventional methods? And secondly, could we start adding new types of tools to the 3D printer, to this gantry system that you saw before, to increase the 15%, maybe up to 50% instead. So we're working on various tools that can do that. Say, attaching a robotic arm that can spray paint, attaching a concrete casting head that can pour concrete in the cavity or pour insulation, et cetera, et cetera.
I thought that was a pretty good answer, Henry. I'll let you be the judge of that. So Philip, thank you so much for joining us on the show today. Really appreciate having you on. And remember, everybody, Dave Cooper Live is partnering with the International Code Council this year, and we will be attending their October event in California. Details are coming on that, but guess what? They want you, the offsite industry, the industrialized construction industry, the leaders, to come to their event this year so you can talk with the leaders of the Industrialized Construction Code Council, the members, as well as all the building officials that are going to come to this show from around the country just to see the latest and greatest and talk to the people in offsite so we can build it better. Pretty cool, huh, Philip?
Sounds great.
Awesome. All right, for the rest of you out there, make sure you thank these sponsors. Philip, don't go anywhere. Thank you so much once again for informing us on COBOD and your 3D technology. I'm Dave Cooper. Thanks for watching. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.